Have you ever thought about a race between you and a slow, pokey tortoise? Of course you have, you're fast. You can run, jump, zoom around. A tortoise just plods along. It seems like the easiest race in the world, right? You would win in a heartbeat. But what if I told you that, according to a very old, very clever idea, you could never, ever, ever catch that tortoise? Not even if you were the fastest runner on the planet. It sounds completely bonkers, doesn't it? How could a speedy human fail to overtake one of nature's slowest creatures? This isn't just a silly riddle. It's a puzzle that has boggled the minds of the smartest people for thousands of years. It makes you stop and think about things we take for granted, like moving from one place to another. Imagine you give the tortoise a little head start, just to be fair. It crawls a short distance ahead. Then the race begins. You run to where the tortoise was, but by the time you get there, the tortoise has moved a little bit further. So you run to that new spot, but guess what? The tortoise has moved again. It's a mind-bending problem that challenges our basic understanding of speed, distance, time. This isn't about real-world running. We all know you'd zip past a tortoise. This is a thought experiment, a brain gymnastic. It forces us to question reality. How do we get from point A to point B? Can space be sliced forever? This race opens a huge can of tortoises thinkers have wrestled with for centuries. Ready to dive in? Let's go. Consider this. Motion itself might be an illusion. So, who came up with this crazy idea that you can't catch a tortoise? The person we have to thank is Zeno of Elea. Zeno lived around 2,500 years ago in what's now Italy, then a Greek colony. He wasn't a scientist with beakers and test tubes. He was a philosopher. A philosopher asks big questions about life, the universe, and everything in it. Zeno was great at questions that made heads spin. He wasn't just being tricky or winning party arguments. He studied under Parmenides, who believed change and motion were illusions, and reality was one unchanging thing, like a photograph. To support that theory, Zeno created puzzles, Zeno's paradoxes, showing our usual ideas about motion can lead to absurd conclusions. He had a whole collection. Besides the tortoise race, there was the dichotomy paradox and the arrow paradox. Dichotomy: to go anywhere, first go half, then half of that, and so on forever, needing infinite steps to even start. Arrow: at any single instant, the arrow isn't moving. If time is instants and it never moves in an instant, how does it reach the target? Before the big race, what's a paradox? It sounds complicated, but it's actually pretty cool. A paradox is like a riddle that seems self-contradictory but might still be true. Say, this statement is false. If it's true, it's false. If it's false, it's true. Brain flip-flop. Paradoxes are funhouse brain teasers where common sense clashes with strict logic. Think of the grandfather paradox in time travel, a loop with no escape that challenges cause and effect. Zeno starts with simple truths and leads to, the runner can't catch the tortoise. The paradox is in our description, not the real world, so we must dig deeper. Alright, let's set the stage for the most famous paradoxical race in history. In Zeno's story, the runner is Achilles, fastest hero alive, a superhero of his day, an Olympic champion and warrior. His opponent? A humble, slow, steady tortoise. Achilles gives a head start. Imagine a 100-meter track. The tortoise gets 10 meters. The gun fires. Achilles at 0, the tortoise at 10. Achilles runs much faster, say 10 times the tortoise. Common sense says he'll catch up in seconds. Zeno's twist. Analyze as smaller stages. First, Achilles must reach where the tortoise started. He hits 10 meters, meanwhile the tortoise has crawled to 11. The gap shrinks, but it still exists. Aha! He made it to where the tortoise was, but the tortoise kept moving. Zeno's analysis: always run to where the tortoise is now, and by arrival, it's moved again. 10 meters, then one more, then a bit more, always a new tiny gap. So what happens if we zoom into those steps? Let's take it piece by piece and see why Achilles seems doomed to be always just a little behind. Achilles is at 10 meters. The tortoise is at 11. The gap is 1 meter. Achilles is still behind. What must he do next? He must run to where the tortoise is. Cover that 1 meter gap. He zips across in a fraction of the earlier time. He arrives at 11 meters, confident, but the tortoise kept moving. At 1/10 the speed, while Achilles covered 1 meter, the tortoise covered 0.1 meters, 10 centimeters. Now it's at 11.1 meters. Achilles is closer, but not caught up. Do you see the pattern? This repeats again and again. From 10 centimeters to 1 centimeters to 1 meters to 0.1 meters, the gap shrinks and shrinks but never quite disappears. Zeno's logic. Achilles must complete infinite smaller tasks. He must cross 10 meters, 1 meter, 0.1 meter, 0.01 meter, and so on. Because there are infinitely many gaps, Zeno argues Achilles can never finish the final step. He's always just a little behind. In this logical world, the tortoise stays forever, one tiny step ahead of a hero. Okay, how does this thinking pop up in everyday life? You try to clean your room. First the clothes, then the comic, then the dusty shelf, then find a cloth. The big task splits into endless smaller ones. Even crossing a room, half, quarter, eighth, 16th, 32nd, Zeno's dichotomy makes a simple walk seem impossible. Analog clocks sweep smoothly. Digital jumps minute to minute. Are space and time smooth like a ramp or discrete like a staircase? Is motion a flow or snapshots? In games, your position is computed frame by frame. Tiny jumps that still get you across. Finite steps, calculated quickly, still complete the journey. The big, hairy, mind-boggling concept here is infinity. The sideways 8, meaning endless, limitless, forever. Zeno says Achilles must complete infinitely many tasks. We're used to finite things. Cookies in a jar, hours in a day. If you tried to count to infinity, you'd never finish. So it feels like infinite steps mean infinite time. The trap Zeno sets. He makes us mix up infinite number of steps with infinite time or distance. That's the confusion. But infinity comes in different flavors. Look at Achilles' gaps. 10 meters, 1, 0.1, 0.01, and so on. Each step shrinks rapidly towards 0. The time for each step shrinks too. 10 meters quickly, 1 meter quicker, a centimeter in a blink. The intervals get infinitely small. Here's the key. You can add up infinitely many shrinking pieces and still get a normal, finite total. Eat half the pizza, then half of what's left, then half again. Infinitely many slices, but only one entire pizza total. Zeno discovered the puzzle long before math had the tools to explain it clearly. Those tools are coming up next. For thousands of years, people argued about Zeno. Mathematicians finally gave a clear answer with calculus, the math of change, motion, and infinity. Newton and Leibniz gave us the language to defeat the tortoise. Calculus handles adding infinitely many shrinking numbers via convergent series. Geometric sums converge. S equals A over 1 minus R. Achilles runs 10, then 1, then 0.1, then 0.01. Add them up and the sum approaches 11.1111. Exactly 11 and 1/9 meters, finite. If 10 meters takes 1 second, then 1 meter takes 0.1, then 0.01, and so on. Total time about 1.111 seconds. Achilles catches the tortoise 11 and 1/9 meters from the start at about 1.111 seconds. So, the paradox is solved. Zeno assumed infinite events need infinite time. Math shows not when intervals shrink towards 0. Reality behaves like calculus. Motion is smooth and continuous. You cross in a single flow. The paradox was in the language before calculus, not in reality. We traveled to ancient Greece, met a puzzle master, wrestled with infinity, and saw math save the day. We took apart Achilles and the tortoise, piece by logical piece. Now you know the secret. Infinity can make a finite race look endless, but convergent sums resolve it. These questions inspired tools that build airplanes, bridges, and send rockets to space. Back to the start. The race is on. It's you against the tortoise. It gets a head start. The gun fires. You know the logical trap. And the mathematical solution. Those infinite little steps happen in a flash. Could you beat the tortoise? Of course you could. You'd zip past with new appreciation for how elegantly math describes our world. Now, go consider that.